Good morning once again. This is Richard, and this is Basic Solution Academy. This morning, we want to quickly see the first topic on the list of topics in our mathematics. Now, let's see indices. Indices. They are treating a topic in mathematics. Indices. Now, we are going to first and foremost know what a term is. A raised by x. This is a term. This as a whole is a term, while this can be regarded as a power. It can also or index or an exponent. Then this is a base. So this is base A raised to power x. Base A raised to power x is a term. Now, there are laws we need to know when we are trying to solve any indices related problems. Now, these laws are as follow. Number one, the first law, sorry, states that if we have a base, if we have a term, multiplying another term, both terms having the same base but different power. What does this become? The law says that take a base since they are the same, a raised power, then add the power x plus y. Now, let's see an example under this. Now, assuming we have 2 raised power 3 times 2 raised power 5, or 2 raised power 2. The law states that take a 2, then add the power 3 plus 2, which is 2 raised power 5. Now, normally, if we are to solve this arithmetically, saying 2 times 2 times 2, which is 2 raised to power 3, then 2 raised to power 2, 2 times 2. This give us 8. This gives us 4. 8 times 4 will give us what? 32. Now, what's 2 raised to power 5? 2 raised to power 5 is 2 times 2 times 2 times 2 times 2. 2 raised to power 2 will give us 2 times 2 will give us 4. Another 2 times 2 will give us 4. Then times 2. 4 times 4 will give us 16 times 2, which is also 32. So instead of going through the hassle of the arithmetical um, method of solving it, we can use the law of indices and we will still arrive at the same answer. Now let's see the second law. The second law is almost similar, but with just a different sign of operation. For instance, if we have same terms like a raised to power x dividing a raised to power x divided by a raised to power y. The law states that take a base a raised to power x minus y. The numerator, the power of the numerator minus the power of the denominator. The numerator is the I think if we place this in form of a fraction like a raised to power x over, so it will be a raised to power x will be our numerator, y a raised to power y will be our denominator. So this is what the result will be. Let's take an example of this too. Let's use the same example. A raised to the power 3 divided by a raised to the power 2. It should give us a raised to the power 3 minus 2, which is a raised to the power 1. We don't normally indicate the 1 there because this literally means a single a, which is a raised to the power 1. Now, okay, let's turn this into an example. Maybe 2 raised to the power 3 divided by 2 raised to the power 2, which is take it to 2 raised to the power 3 minus 2, which is 2. So we don't say 2 raised to the power 1, we say 2 because it's a single 2, and that's what it is. So that's it. Going by arithmetic method, 2 times 2 times 2, which is 8, divided by 2 times 2, which is 4. 8 divided by 4, the answer will be 2, which is the same 2. So that's that about the first two laws. Okay, let's proceed to the third law as we clean the board. Let's clean this as well so that to give us enough space to write, we can just note it here. A raised to the power x, this is a power, an exponent, or an index. This is a base, and the whole is a term. Okay. Now, let's see the third law. Now, for instance, we have two different bases operating on each other, but with the same powers. How do we go about that? Now, look at the board. Let's call it law 3. For instance, we have a raised to the power. Okay. For instance, we have x raised to the power a times y raised to the power a. This states that we'll multiply the basis, which is x, y, then we'll power it with a single power, since the powers are the same. For instance, if we have 3 raised to the power 2 times 2 raised to the power 2, this is that 3 times 2 raised to the power 2, which is 6 raised to the power 2, which is 36. Arithmetically, if we want to do it, this is 3 times 3 times 2 times 2. 3 times 3 is 9 times 2 times 2, which is 4. 9 times 4 is 36. So you see that they are equal, they are equivalent. Now, let's see, law number 4 is also similar. It's just the operational sign. that is different. X raised to power a divided by y raised to power a will have x over y raised to power a. Let's see an example. Same example. 3 raised to power 2 divided by 2 raised to power 2. Okay, let's make this 4. 4 raised to power 2 divided by 2 raised to power 2. Then we'll have what? 4 over 2 raised to power 2, which is solving the bracket. This cut this to give us 2, that's 2 raised to power 2, which is what? 4. Now, looking at it arithmetically, 4 raised to power 2 is 4 times 4 divided by 2 times 2. 4 times 4 is 16 divided by 2 times 2 is 4, which is 16 divided by 4, which is 4. And see the equivalence. They are equal. Okay, let's go to law number 5. Law number 5 is simple. Law number 5 says that anything raised to power 0 equals to 1. That is, x raised to power 0 equals to 1. Anything raised to power 0 is equal to 1. Example, e.g., 10 raised to power 0 equals to 1. Now let's see law number 6. Let's allow some time for you to write. Okay, let's see law number 6. You can always pause in between lectures to note whatever it is. Now, law number 6 states that if a term is carrying a negative power, x raised to power minus n, x raised to power minus n, a term carrying a negative power, this is x raised to the power of minus n, a term carrying a negative power, then the result will be 1 over x raised to power n. The reciprocal of it, the term with the negative power, the reciprocal of it is the result. Without the reciprocal of the term without the negative power, the reciprocal removes the negative power. For instance, if we have 3 raised to power minus 2, the result will be 1 over 3 raised to power 2, which is 1 over 9. Now, rule number 7. This rule number 7 has 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 a similar pattern to rule number 6. For instance, what if the term is a fraction and it is carrying a negative power with a bracket? For instance, x over y raised to power minus n. x over y raised to power minus n. The law states that the result of these will be this, the fraction for the negative power to go off, then we'll take the reciprocal of the fraction. Then the result becomes taking the reciprocal of the fraction without the negative power. It becomes y over x raised to power n. The minus has been removed because this, the numerator and the denominator has swapped places. They've swapped their position. So, and that is the reciprocal of this. It's just like saying 1 divided by this. So that's that. So for instance, we have, for example, AG, AG. For instance, we have maybe 3 over 2 raised to the power minus 2. The result becomes 2 over 3 raised to the power 2. And that gives us, this is 2 squared over 3 squared. This is 4 over 9. Now let's see rule number 8, law 8. Law 8 states that what if we have powers, the power of a term multiplying another power outside. For instance, we have x bar a, b. These are both, a and b are both powers. This becomes x raised to power ab. A will multiply x raised to power ab. The power multiplies themselves. For instance, let's do an example. E.g., 3 raised to power 2 bracket 3. This becomes 3 raised to power 2 times 3 on 3 raised to power 6. That's 3 times 3 times 3 times 3 times 3 times 3. 3 times 3, 9. 9. 9. 9 times 9, 81 times 9. 81 times 9 will give us 9 times 1, 9. 9 times 8, 72. 729. So that is that. Now let's see rule number 9. Rule number 9. Rule number 9 states that what if we have a power, a term that is having a fractional power? X raised to power 1 over a, or a raised to power 1 over x. A raised to the power of 1 over x. This rule states that the numerator of the fraction will root the base. The numerator of the fraction will root the base. That is, if the denominator of the fraction, the denominator of the fraction will root the base. That is, and the result will be like this. That is, if the numerator of the fractional power is 1, which is unity, if it is 1. But rule number 10. Now, added a little clause to that. that what if the fractional power, what if they are both whole numbers that is not 1. For instance, we have a raised to power x over y. The result becomes the denominator will still root the base, while all of it, the entire result, will now be powered by the numerator. I hope you understand this. Now, I want you to understand that the reciprocal of a number is 1 divided by that number. Reciprocal can also mean the inverse of a value or a number. Now, having seen these 10 laws, we will solve examples in categories as it relates to the laws. The problems, we group them into categories so that when you see a particular problem, you will be able to identify the law that best suits the solution of that particular problem. Okay, let's proceed. Let's see the category 1, indices involving number power. Indices involving number power. Now let's see some problems. It says simplify. Simplify 27 raised to the power 1 over 3, then bracket 2. Here, we can spot 2 laws here, law number 8 and 9. The law number 8 states that if we have powers in brackets, we can multiply them, multiply the powers. We can go through that route, and we can also decide to treat law number 9 first. That if we see a particular base carrying a negative, a fraction, we can just, apply law here, then solve our problems. So I think we should go through the route of 8, then come to 9. Law number 8 says the power multiply themselves, which is 27 raised to the power 2 over 3. Then this will now result in using law number 10, which states that the denominator will root it, while the numerator will power the whole result. Cube root of this is 3 raised to the power 2, which is 9. Now let's see another example. Still on this category. Now simplify 36 raised to the power half times 64 raised to the power minus half times 5 raised to the power 0. Now putting all the law into consideration here, we have this rule which says that if we have a power fraction, the numerator will root to 36 times this will be 1 over 64 raised to the power half, which will now be like this, then which will eventually result into those 64 times 5 raised to the power 0, which is 1. Now root 36 is 6. 6 because 6 times 6 is 36. That is 1 over root 64 is 8. can multiply out 6 times 1 times, or we can cut it. This here, 2 here, 3, 2 here, sorry, 2 here, 4. We can multiply out, which is 3 times 1 times 1, which is 3, over 1 times 4 times 1, which is 4. So that's our final answer. Now, let's see another example. Example 3 says 9 raised power minus 1 over 2 over 27 raised to power 2 over 3. Now we'll treat them separately, individually. This on its own means 1 over 9 power half. This is divided by, let's just make it linear, 27 raised power 2 over 3. Now, over 1. This is 1 over root of 9 divided by 3 all into the power 2. This is 1 over 3 divided by cube root of 27 is 3. 3 squared is cube root of 27 is 3. This power 2 becomes 9. So this is 1 over 3 divided by 9 over 1. Now, you know when we have divide operating between two fractions, this is fraction, this is another fraction, and divide is operating between them. For this divide to become times, the fraction on our right hand side will swap, or we'll take the reciprocal form for this to become multiplication. You know, we say reciprocal is 1 over something, or when the value of something, the value of the when the numerator and the denominator swap position, 1 over 3 times 1 over 9, which is this has come down and this one gone up. That's 1 times 1, 1 over 3 times 9, 27. So that's our final answer. Okay, now for this case, we have some drill assignment to solve. Then after solving, you put your answers on the comment section. So that like 5 of it. Number 1, simplify. Simplify 125 raised power minus 1 over 3 times 49 raised power minus 1 over 2 times 10 raised power 0. Number 2, 1 over 4 raised power minus 1 on number 1 over 2. Number 3, 16 over 81 raised power 1 over 4. Number 4, 4 raised power minus 1 over 2 times 16 raised to power 3 over 4 over 4 raised to power 1 over 2. Then lastly, number 5, we have 0.027 raised to power minus 1 over 3 minus raised to power minus 1 over 3. You can always pause your video to be able to write down anything. Now let's see case 2. Let's rush through case 2. Case 2, indices involving power in simple linear equation. Indices involving power in simple linear equation. Let's use some examples. Number one. Number one. If 3 raised to power x equals to 27, what is x? Now, solution. When we have a problem like this, what we'll do is we'll have to express both sides in such a way that they will have the same base. We'll express both sides, which is our left hand side and our right hand side, in such a way that they will both be in same base. In this case, they will also both be in base 3. What I'm trying to say is when you see a problem like this, express both the left hand side and the right hand side in a common base. Express them such that they will both have a common base. Now in this case, this is already in base 3, which is uh, almost the smallest base. Then this can also be expressed in this base. So solution, 3 raised to power x equals to 3 raised to power 3, which is also equals to 27. Then the bases can cut themselves out, so x equals to 3. Let's see example 2. Example 2, if 4 raised to power x equals to if 4 raised to power x equals to 2 raised to power 1 over 2 times 8, find x. Here we also express them in common base. This is 2 raised to power 2x equals to 2 raised to power half times 2 raised to power 3. This can be treated with the first law. 2 raised to power 2x equals to 2. Take 1, 2. Then 1 over 2 plus 3, which is 2 raised to power 2x equals to 2 raised to power. Now, if we are adding two fraction, which is 2, 2 into 1, 1 times 1, 1 plus this and this, 2, 2 times 3, 6. This is 2 raised to power 2x equals to 2 raised to power 7 over 2. Our 2 can go. Our 2 can go. Then we have 2 raised to power x equals to 7 over 2. Now let's proceed with our class. Still on case 2. Number 2. If 4 raised to power x equals to 2 raised to power 1 over 2 times 8, find x. Now, like we did in our first example, express them all in a common base. So this is 2 raised to power 2x equals to 2 raised to power 1 over 2 times 2 raised to power 3. This is 2 raised to power 2x equals to 2 raised to power half times 2 raised to power 3. Okay, over 1. We are adding both fractions. 2 raised to power 2x equals to 2 raised to power. The LCM is 2. 2 into 1 times 1. 1 plus 1 into 2. 2 times 3 is 6. That's 2 raised to power 2x equals to 2 raised to power 7 over 2. So the base can go since they are common bases. So we have 2 raised to power 2 times 2x equals to 7 over 2. So we can cross multiply. That is 2x times 2 equals to 7. That is 4x equals to 7. X equals to, divide both side by 4. 7 over 4. But we can't leave our answer like this because the numerator should not be bigger than our denominator. So we'll say 4 in this to give us can go 4 can go in 7 one time to remain 3 over 4. So we have a mixed fraction as our answer. Now let's proceed to the next one. Wasting time. We have, they said, given 9 times 3 raised to power 1 plus x equal 27 raised to power minus x. Find x. So all we need to do is bring them down to a common basis. 3 raised to power 3, 3 raised to power 2, that's 9 times 3 raised to power 1 plus x equals 3 raised to power 3 bracket minus x. This is, you can use the first law here to solve this. Take one of the three, then add the power plus 1 plus x. Assuming it's minus that is here, we would have done this thing as a bracket, but it's plus because the minus will change the sign in the bracket. But in this case, it's okay. Equals to 3 raised to power minus 3x. So the base can go, and 2 plus 1 give us 3 plus x equals to minus 3x. Now we'll collect like terms. Now, when we want to collect like terms, we should be mindful of our sign. We should collect our like terms in such a way that the negative sign can be completely eradicated if we can. So, eradicating this negative sign is bring this to this side, which is x plus 3x equals to this 3 to the other side equals to minus 3 because it is plus here. So on getting to the other sign of equal to, it becomes minus. So this plus this will give us 4x equals to minus 3. X dividing both sides by 4 to make our x stand alone. So our x equals to minus 3 over 4. So that's our final answer. So that's that. Now let's see. Let's give some drill assignment in which the answer should be submitted on our comment section. Now, classwork, drill assignment. Drill assignment for case 2. Number 1. Find the value of t. Find the value of t for which 64 over 27 equal to minus equals to 3 over 4 raised to power t minus 1. Then number 2, x to the power 4 equals 0.25 raised to power 2. Find x. Number 3, if 9 raised to power 2x plus 1 equals to 81 raised to power x minus 2 over 3 raised to power x. Find x. Then lastly, given that 3 times 9 whole number 1 plus x equals 27 raised power minus 2 minus x. Sorry. Find x. So that is the drill assignment for case 2. Now let's quickly see case 3. Case 3. Indices involving power in simultaneous linear equations. Let's see examples. 1. If 3 raised power y plus x equals 9 raised power y plus x and 2 raised power x minus y equal 8 raised power x minus 3. Find the values of x and y. Find the values of x and y. Okay, let's see the solution to this. Now, if we have a problem like this, the first thing we do is to place them in simultaneous form and label our equations. So we have 3 raised to power y plus x equals 9 raised to power x plus y. Equation. Okay, we can resolve this first. Bring out their common basis. 3 raised to power y plus x equals to, sorry, this is y plus x. 3 raised to power y plus x equals to 3 raised to power 2 bracket y plus x. So 3 goes 3, then y plus x equals to 2y. Expand plus 2x. We can collect our like terms. Let these ones come here. So this is 0 equals to 2y minus y plus 2x minus x. So 0 equals to 2y. 0 equals to 2y minus y, y plus 2x minus x, x. So these are equation 1. Then for the second one, we have 2 raised to power x minus y equals to, make them, okay, 8 raised to power x minus 3. Bring them to common is 2 raised to power x minus y equals to 2 raised to power 3 bracket x minus 3. As we can see, the base goes x minus y equals to 3x minus 9. So we can collect like terms from here. Take this here and bring this out. You understand? It can be like this, you can bring this to the other side, but I always encourage my students to resolve whatever equation they have in such a way that they can avoid the minus sign. So we can bring this to this side, bring this 9 to this side, making 9. This minus here. It comes here, it becomes ordinary 9. Then we have 3x here already. Bring this x to this side, becomes minus x. This is y, bring y to this side. This minus y, bring it to this side, becomes minus, becomes plus y. So we have 9 equals 3x minus x will give us 2x plus y. So that's our equation 2. So we have our equation 1 and 2 already from this stage. So let's clean the board. As we just leave our labeled equation out. So we can twist these, we can bring this to the other side, just like reversing it, or just for for not to confuse anyone, we can leave it like that. So we can say 0 equals to y plus x. Still the same thing. But we can align the variables under same variables. This 9 equals to y, bring it under y plus then x under x. So in simultaneous equation, we have two methods of solution. Is either we'll do it by substitution method. Substitution method is when we make one of the variable, when we make it the subject of the formula, then we'll now substitute it or impute it into the second equation. We impute the value of it into the second equation and we'll solve from there. But most times I prefer elimination method. Elimination method is we try in elimination method we try and see how to eliminate one of the variable so that the other variable we'll be able to find the other variable. So in this case now, we will try and eliminate y. The signs between the equations, if they are the same, we subtract, but if they are different, we add. If they are the same, we subtract. If they are different, we add. What I meant by that is, if it is plus plus, we subtract. If it is minus minus, we subtract. If it is plus minus, we add. If it is minus plus, we also add. So in this case, it is plus plus. The signs are the same. So we subtract. So subtracting equation 2 from equation 1, we have 0 minus 9. That will give us minus 9 equal to y minus y, that's 0. Then x minus 2x, that will give us minus x. In this case, minus on the on minus is on both sides, so they cancel. So 9 equals to x. If 9 equals to x, by implication, x equals to 9. Now we have a drill assignment here for you. This is the drill assignment. Two raised to power x plus y equals to 8. And 3 raised to power 2x minus y equals to 27. Solve the simultaneous equation. Okay, quickly, let's proceed to the second example. Example 2. It said solve the equation 4 raised to power x plus 1 minus 9 bracket 2 raised power x equals to minus 2. Now this is called an exponential equation. It is called an exponential equation. What we'll do here is we will bring all the term to their original form. We'll bring them to their origin. We'll take them to their original form, the way they were before the law is being applied on them. For instance, this the law of indices has been applied on this for this to be like this. But originally, it is something like this: 4 raised power x times 4. Because this 4 is what gave rise to this one here by saying take one of the base, then add the power, because this is 4 raised power 1. Now, let us proceed. Then minus 9 raised power 9 times 2 raised power x equals to minus 2. Now, make all the term to be in a common base, the lowest common base. For instance, this 4 is 2 raised power 2, right? And it has a power of x times this is 4. And leave this one like this. Can leave it like that. It's just an attaché. Then this is 9. 2 raised power x equals to minus 2. Now, I hope you know that, when we have a law in which there is a bracket between the powers, they can multiply themselves. This is 2 raised power 2x times 4 minus 9 bracket 2 raised power x equals to minus 2. Now, 2 raised power x, this can be 2 raised power x. We want to bring out, a common term, a factorizable one. 2. But what I just did here was just to bring in the x and take out the 2 times 4 minus. Look at this. 2 raised power x is here, 2 raised power x is here. I can use something to represent it. For this to take the form of a quadratic form. A general quadratic form is a raised power x squared, ax squared plus bx plus c equals to 0. Where this is the coefficient of x squared, and this is the coefficient of x, and this is a constant. This is like this. This is a quadratic equation. It is a quadratic equation. It's a quadratic equation because the highest power of the variable there is what? 2. The highest power of the variable is 2. Eh, for a linear equation has the highest power of a variable in a linear equation is 1. Is unit is 1. Then the highest power of variable in a quadratic equation is 2. So this is a general quadratic equation, and we can bring out this form of equation from these problems that has been resolved to this level by saying let P represent 2 raised power x. Therefore, anywhere we see 2 raised power x, we just put our P there. That gives us P squared, because this is 2 raised power x, this is P, times 4 minus 9p equals to minus 2. So this is 4p squared minus 9p. Bring this 2 in for it, that's our constant, for it to take the exact form of a quadratic equation. Plus 2 equals to 0. 4p squared minus 9p plus 2 equals to 0. Now, for a quadratic equation, there are different methods of solving a quadratic equation. We can either factorize, use general formula method, or use a completing the square method. There are other methods. There are other methods that we can use to solve a quadratic equation. But for now, let's try factorization method. Now, in factorization method, the rule there states that multiply the first term and the constant together. This gives us 8p squared. Then we'll find two factors of this such that those factors, when we add them, they should give us the middle term. Now look at this. Such factors could be the factors of 8p squared. Factors of 8p squared could be 2p times 4p. It will give us 8p squared, right? It could be 8p times p. It will also give us 8p squared. Now, in this case, which one is likely to give us this if we add them together? If we add this together, on adding this together, this will give us 6p. On adding this together, this will give us 9. So now, for us to now get a 9p squared, what do? We need to know where we are going to put our minus. So minus here, minus here. If we multiply it, it will still give us 8p squared, and if we add it, it will give us 9p. So the next step of the solution says that instead of imputing your 9p square, you know the addition of this will give us 9p. So let's just put this there instead of rewriting the original equation the way it was. So this is 4p squared minus 8p minus p plus 2 equals to 0. Minus 8p minus p will give us 9p. So replacing it. For us to be able to factorize this, then group this. Group this. We'll look for a factor here. What is common to both sides? 4p, I guess. This will remain p. 4p goes in this remain p minus this goes in this remain 2. What's the factor here? Minus 1. In this it will be p. In this it will be minus 2. Note that when you are solving a quadratic equation, what the factor that will be here must be the same as what will be here. That is one thing that is an indicator that what you are doing is right. I hope you understand what I'm saying. When factorizing, after bracketing, doing your bracketing them into um, groups, you now factorize what will be here must be what will be here. So we'll now factorize. We will factorize these two. We'll factorize this because this is a single expression. This and this. So what is common to both is p minus 2. P minus 2 is here. P minus 2 is here. So take one p minus 2. P minus 2. P minus 2 in this single expression will remain 4p. P minus 2 in this single expression will remain minus 1. So we just bracket this. Is all equals to 0. Now, there is a saying that anything multiplied by 0 is also 0, which means one of them is equal to 0. Either this or this is equal to 0. So we now come up with another expression that p minus 2 equals to 0, or 4p minus 1 equals to 0. You can find p here. P equals to 2. 4p equals to 1. Bring out this 1 first. Divide both side by 4. P equals to 1 over P equals to 1 over 4. P is equals to 1 over 4. How do you know this can also be expressed as 4 raised power minus 1? Good. But we said let P represent 2 raised power x. Therefore, for this, 2 raised power x equals to 2. You know, how do you know that there's 1 there, an imaginary 1? 2 cancel to the base, cancel themselves. X equals to 1. Or 2 raised power x equals to 4 raised power minus 1. Make them to be with a common base. 2 raised power x equals to 2 raised power 2 bracket minus 1. 2 raised power x equals to 2 raised power minus x equals to minus 2. So x equals to 1, x equals to minus 2. And we want simplify number 2. Number 3. Thank you, Jesus. That is the end of our lecture for today. But the important aspect, this is the aspect where we introduce a supreme personality We do it just for 1 or 2 minutes in the course of the lecture. This Supreme Personality is a master, is a master that is also a friend, that is also a companion, a helper, a solution giver, a problem solver. He is the one that can bring out something from nothing. You can help with any situation. He understands any kind of problem. And the name of this personality is Jesus. Is Jesus. Is an awesome God. And is also looking for everyone that will want to seek him. So to seek him is a great gain. It is the reason why we do what we do. And we are using this opportunity to let people know about his goodness. I pray as we watch this video, God will help